Okay, it's been a while since we've gone over an infinite series test, so I thought we'd get back into it with one of my favorites, which is the ratio test. Now, like all the infinite series tests, you can test for convergence or divergence, in this case, both. Uh, and it's important to note that you should use this whenever there's a factorial or an exponential involved in the series. So these are the conditions. If the series, the infinite series of a sub n, it will converge if the limit as n approaches infinity, absolute value of a sub n plus 1 over a sub n is less than 1. So you're essentially, a sub n in this case, you just replace every instance of n with n plus 1. Now, the infinite series a sub n will diverge if the limit as n approaches infinity, absolute value of a sub n plus 1 over a sub n is greater than 1. And it will, if it happens to be equal to 1, then it is inconclusive, and you should use a different test. Okay, so that was it for the explanation. Let's get into practice problem 1. So we're going to take the limit as n approaches infinity, absolute value of a sub n plus 1 over a sub n. So first, let's just write a sub n. It's just going to be the function part of the series. In this case, n times e to the power of 2n. So as I said earlier, for a sub n plus 1, you're just going to replace every instance of n with n plus 1, which in this case, well, first let's write out this first part over here. So n plus 1 times e to the power of 2n plus 2, because we're distributing the 2. And e to the power of 2n plus 2 is actually equal to e squared times e to the power of 2n. That's just algebra. So we can write this out here, and without really simplifying it further, we can see that this e to the power of 2n simplifies with the other e to the power of 2n. And that just, they cross out and they equal 1. So we can say that this is equal to the limit as n approaches infinity, absolute value of e squared n plus 1 over n. Now, if we were to place every instance of n with infinity, we would see that we have e squared times infinity plus 1 over infinity. Now, these two essentially cancel out because infinity plus 1 over infinity is equal to 1 because the two are essentially equal. And so this entire thing is equal to e squared, which happens to be greater than 1, which means this series over here diverges by the ratio test. All right, this one is a bit more complicated to some extent. Let's just write out the e limit first. And we can see that it's equal to negative 1 to the power of n plus 1, which is equal to negative 1 times negative 1 to the power of n times 3 to the power of n plus 1, which is equal to 3 times 3 to the power of n, all over n plus 1 binomial. And as you know, binomials, n plus 1 factorial. And as you know, factorials are the product of itself and every other variable smaller than it. So n factorial is actually equal to n times n minus 1 times n minus 2. Sorry, n times 2. And so on. This goes on forever. So if we were to replace this n with n plus 1, we'd end up with n plus 1 factorial, which is just n plus 1 times n minus 1. And again, this also goes out forever. So rather than writing n plus 1 binomial, in order to simplify it later with this, instead of writing n plus 1 factorial, we want to simplify that term with the other n factorial. So instead of writing n plus 1 factorial, we can just write n plus 1 times n factorial. And you're going to do this a lot if you ever encounter factorials while using the ratio test. So we'll just write that out. N plus 1 times n factorial all over this is just the regular a sub n denominator. So we're just going to write out the usual function over here. And this is a bit odd looking. So we can simplify this such that it's equal to limit as n approaches infinity, absolute value of -1 times -1 to the power of n times 3 to the power of n over n plus 1 times n factorial. Now we're just rearranging the fraction. That's all we're doing, and it just makes it easier to simplify. Okay, and now we can cross out some of the terms. So -1 to the power of n, that crosses out over here. 3 to the power of n here and here. N factorial here and here. So we end up with limit as n approaches infinity, -3 over n plus 1. Now this is equal to 0 because if we replace n with infinity, we end up with absolute value of -3 over infinity, which is actually equal to just 3 over infinity. But that doesn't matter because whenever you have a infinity in the bottom, then it's equal to 0. So this entire limit is equal to 0, which is less than 1, which means that this series, this infinite series, converges by ratio test.